All right, here are the inverses. The whole point of inverses is that your x and y will switch places, either on the graph or as far as your domain and range. So as far as filling out your domain and range here as the tables are concerned, if you read your domain over here for the function for the inverse, so here's your range from the domain of the function. Now looking right here at your domain and range, your question is the inverse of a function a, also a function. If you remember your vertical line test, the vertical line has to go through the function once and only once. And if you're looking at the inverse as a function, then it should go through the vertical line or your pencil test once and only once, meaning that your x's are all different. So are these x's all different? Well, yes, they are. So yes, it's a function. Then we look over here, here's your function, and then here is your inverse. So look at your range, which is now the domain. Would these x's be all different? Well, let's write them as ordered pairs. That usually helps me decide. So if you write this 2 with this 1, that's a point, and then this 2, because of the arrows with a 4, these x's are not different. So this inverse is not a function. It would not pass the pencil test because we would go through that x value twice. All right. Here's a function that has been graphed. How would we state the inverse? By graphing it or rewriting the ordered pairs. Remember, replace the range in the domain. Let's look at it on the graph. Let's look at the ordered pairs. Okay, so here is 1, 2. Here's 2, 1. Replace those. Here's 4, 1. Here's 1, 4. That's the inverse. Here is -4, -2. That inverse is -2, 4. Here is 0, -3. Here's -3, 0. And here they are all listed. All right, so what do you observe about the graph? The function and its inverse in relationship to the line y equals x. Well, take a look at these points. Here is each point and its inverse. How do they look? Okay, the points reflect across. This y equals x line. All right, next, here are some steps if you're going to find algebraically the inverse. Here's how we graph it, kind of like with the points, but what if you actually have a function like 3x plus 4? Well, if we have the function 3x plus 4, first you graph the point 0, 4, and then you have your slope up 3 over 1, which is hard to graph on this graph itself, so let's go up 3 and over 1 again, and this goes by 2, so a little bit harder. So I went up twice, so I went up 6 and over 2, and then I can go down 6 and over 2, and there's my function. So let's look at that function graphed. The inverse of this y-intercept will be 4, 0, so here's that point. And if I use that slope and I go up 3 and over 1, and I go up 3 and over 1 again, which is essentially up 6 and over 2, here is that inverse. So there it is, graphed. So, or the inverse of that slope would be actually, I guess, like up 2 and over 6. I didn't realize I had done that. So, excuse me. So you would reverse your slope as well. But the other thing too would be this is 2, 10. This is 10, 2. So we reverse both of those points. And in class, we will do this algebraically. So the easiest thing to do graphing, you have this point to reverse. We have the second point, 2, 10. Let's inverse that point, 10, 2. And we have a function. So graphing is easy. You get 2 points. You can reverse and inverse those 2 points. Flip the x. All right, that's it. Those are your notes. Let's get ready and do inverses tomorrow in class.